Hans pork processing plant. I don't know what you call it. I guess they do everything to them there. And when they're making bacon, it's amazing because, you know, it just smells like bacon for a mile, and my kids and I love it. So if you don't eat pork somewhere and I've offended you, sorry about that. But this morning, as I'm waiting to make the right-hand turn, there are workers blocking off the whole road because this tractor-trailer truck is backing into the plant, so I guess they can load everything onto this refrigerated truck. And it's a huge trailer behind it, just huge. And they park really tight. The employees, I don't think they have parking lines. They park really tight. And he is literally, I have just this, everybody else is irritated, I'm sure. I just have, now I'm off the mic, so I have to stop. So I just have this whole new appreciation for tractor-trailer drivers because it's all angles. Somehow he gets this enormously long truck in between these tightly packed rows of cars, and there's no margin for error. And I thought he did it pretty quickly. It didn't take more than one set of traffic lights for him to do it. He had to wiggle out once and wiggle it back in, and I'm just thinking it's all angles, it's all math. Somehow, you know, I think I could drive a tractor-trailer truck forward, maybe, if I can just drive straight all the time. But there's no way. There's no way I could back it up. There's no way. Yesterday I saw one, you know, go from Main Street on Hampstead down basically what I would consider an alley, and it's all math. So anyway, today is science, and I'm going to tell you my story about science before we start talking about and doing science today, because I thought, what better way to talk about science than to do science? Because elementary school science is still fun, it's still hands-on, but we're laying that foundation that we go back later and say, remember when we did that in elementary school? And the best experiments they always remember. And then we get to say, well, here's the chemistry behind it, here's the physics behind it, here's the biology behind it. But in elementary school, we just get to have fun. I am a product of 13 years of public school. I did not become a Christian until I was 15. So I had 13 years of public school education science in me. I loved elementary school science. I loved it. We did the best projects. We learned amazing things. It was so much fun. Junior high, 7th grade was okay. 8th grade was just awful because we're doing all these things and we're creating all these things, and I'm thinking, why? What's the point? I don't understand why it's just getting harder and more complicated. By high school, I hated science. That's my true confession. My science teachers knew this. They were just, come on, I'll put you with this lab partner and he can do all the experiments and you can write up all the lab work. So I didn't really care for it. But I think the biggest reason I didn't like high school science because my thinking was here and all of science was here. I didn't understand the why. I didn't understand how things worked. I didn't understand why things worked, and I definitely didn't understand why I needed to know why things worked. So I come to a relationship with Christ this summer after 10th grade. And I still have, I think, a year of science at the high school level to finish up. But that was my earth science year. I took the minimal sciences in high school because I didn't have to. I was going in for art for college, so I didn't really have to take chemistry and physics. So but all of a sudden, earth science had a little bit more meaning. Not quite, but a little bit more meaning. And I thought, well, this could be interesting. And it was better that year. It was interesting. But it wasn't until I started teaching my kids science. It took me a long time to get over 13 years of evolutionary training. And really, when you're taught from an evolutionary point of view, there's really no reason to understand why. There's really no, if you think about it, there's no reason to think about, well, why did it happen? It just happened. It was a big bang. Single-celled creatures started developing in ooze, and eventually they melded together somehow to create creatures that had gills and then lungs and then legs, and we crawl out of that ooze, and it takes billions of years, and somehow we come out of all of that. Somehow the world around us just happens. So there's really no reason, if you're looking at things from an evolutionary point of view, as a child, as a school-aged person, to really think about, well, why? Because you're just fed this for 13 years, and you think, it's just the way it was. It's just, we have all this science to prove it. And it wasn't until my early 30s that I really had to start grappling with creationism versus evolutionism. And that's when I was in a Bible study that year, a really intense Bible study, and we were doing Genesis of all things. And a woman in my group, when we got to the days of creation, and I'm still not knowing, I'm still clinging to that verse in Peter where it says, to the Lord a day is 1,000 years, and 1,000 years is if a day. So I'm thinking, I don't have to really change my thinking except to know now that God was behind all of it. But she sat in that group that night and said, I believe in a literal 7-day creation, 7 24-hour periods. I sat there and I thought, I don't know how you do that. I just don't. But as we went through the study, and I had enough sense to think she's like 15 years older than me, so I'm going to keep my mouth shut, because that would just be really, every now and then I have those moments where I think, oh, keeping my mouth shut right now is a really good thing, because for every one of those, I'm sure I have 3 where I think, oh, I shouldn't have opened my mouth, and I did it anyway. But I really started to pray about that, and through the course of time, I started to see if God made everything for His glory, if He spoke it into creation, if the Spirit hovered over the face of the water, if the Trinity was present, if God's speaking it and Jesus is making it happen and the Spirit's in all of it, then why can't it be 7 days? Why can't it be 7 24-hour periods of time? And fortunately, all of this started happening, and I'm praying about this, and God is working this out for me before I started homeschooling. So when we get to homeschool science, my perspective changed. And when my perspective changed, and I started teaching it from the point of view of, look what God does. We talked last month about how God uses math. Look at what God did. God created science. He created everything. He spoke it out of nothing. As good as we are as image-bearing human beings with intelligence that God has given us, we can't make something out of nothing. It's not possible. We just can't pull something out of nothingness and say, look what I made. And everything that we make is from these God-given raw materials that are all around us. So when I started teaching science from God did it, I don't know how He did it, but it's okay. We can look at science now in a whole different way of saying, this is God's creation. This is what He did. So for me, elementary school science is awesome because we just made it hands-on, and we connected it with Genesis, and we connected it with the first chapter of John to say, in the beginning God created everything. So I have a few examples. While I set some things up here, we're going to have some science experiments going. I'm going to let you do science experiments today so you can work with a partner. We have scientific things. So this is, before I get this out, who can tell me what this is? And if you've already done this experiment at home, don't tell anybody.
It's like what?
No. Okay, so pass it around. You can touch it, but
Don't eat it.
don't eat it, but smell it. Smell it and tell me if you know what, and if you know, don't tell the next person until it gets all the way around. And while you're doing that, I'm going to set up 3 cups of water with the exact same amount of water. When I tell you, you're going to have that aha moment if you haven't figured it out. Okay, so this is a bar of Ivory soap in the microwave for 80 seconds. Now, it was even bigger when I pulled it out. Now, the people that make Ivory soap, and I brought one so downstairs when it's all over and watch it, because it is one of the coolest, cheapest science experiments there is, and the wow factor, I did it for my family last night. They're all standing plastered in front of the microwave like, this is really cool, and I know they're thinking, oh, we can get all the soap and just do this all night long. The makers of Ivory soap tell you that it floats because it's 98 point something % pure. Well, if you put Ivory soap in your bathtub, it floats. If you put Dove's, and I'm not promoting one soap over another. If you put Dove in your bathtub, it sinks to the bottom. Ivory soap isn't any more pure than Dove soap. It's whipped up with air. So in a bar of Ivory soap, so I don't know, I guess we could do economics here too and see ounce for ounce which one's the better deal. You're not getting as much soap as Ivory as you thought. But when you put it in the microwave for 80 to 90 seconds, all of that air heats up and you create these pockets of steam. And this at least twice as big as this when we pulled it out of the microwave. And this is what Ivory soap is. So it's a chemical reaction in your microwave, and your kids don't need to understand all of the chemical reactions, or that there are little pockets of air and they're creating steam, and there's that wow factor. And then when they're in chemistry later, when you circle back around in middle school and high school, you can say, remember that bar of Ivory soap that we stuck? Let's just stick another one in there because it's so cool. So that's elementary school science. Now, I have 5 cups up here, and 3 of them have pretty much the same amount of water. So I am going to get this experiment started. So without pouring water from any of these cups into these 2 cups, without doing anything to mix the colors, I'm going to start out with the primary colors of art, which are red, blue, and yellow. And from those colors, we mix every other color there is except black and white. Art colors are not the same as science colors, so right now we're just working with art colors. Science, of course, we know white is the presence of all colors and black is the absence of all colors. It's exactly the opposite in art. Art, white is the absence of all color, and black is the presence of all color. So I'm going to keep my experiment pure by breaking my stick so that you can't say, oh, she broke her stick. So, does anybody know how we're going to get the water from the 3 cups into the 2 middle cups? Oh, good. This is like so awesome if I have people that are going to be amazed by this. So we're going to take paper towels, and this one will go as I talk. And we're basically, I'm trying not to give a feedback, Ruth, I'm sorry. Okay, so not only are we going to fill all the cups evenly by the time this is done, but we're also going to do some color mixing. And if you don't remember what your primary colors mixed together equal, that's okay. Because we'll find out. We'll have a review. I'll get that one in a second. Ooh. Okay, and then while this one is working, I have one more thing to pass out. This experiment I'm going to do today, minimal cost. Objects from your kitchen, nothing too complicated. Okay, so the last thing, I set this up 2 days ago. It's an egg that I have soaked in vinegar for a couple of days, and you can still see the yolk in there. I'm gonna squishy, and if you bounce a low level, it bounces. So of course vinegar is an acid, and eggshells have a certain amount of calcification in them, and the vinegar eats that away while still keeping the membrane intact. Now if we drop it from way up here, it's going to break, so be careful, but it creates this, this is...
Is it still the regular solidified?
No, still the regular egg yolk. So pass that around. You can have some paper towels if you'd like some.
And this was a raw?
This is a raw egg. It's an egg. You can take it, it's been in vinegar 24 hours. All I did this morning was rinse off the last residue of the shell. Again, we don't need to explain all the science behind these things for our kids to think this is really cool stuff. This is, you can bounce this a little bit and it doesn't break. You can squish it. This experiment is starting to work a little bit.
Is this the actual size of the egg, or is the egg size increased?
The egg size increases just a little bit.
This is a duck egg.
No, it's not a duck egg, it's a chicken egg, but it does increase a little bit. Okay. Okay, so I'm going to talk next, and then we're going to do some more science experiments, and then I'm going to have you do some science experiments.
Susie, with the egg,
With the egg.
what would be the point of that experiment? What do we learn?
We're talking about what acids do. You can also do this with a chicken bone. A chicken bone needs to soak for a week or more. And what the vinegar did as an acid was it decalcified the shell. It ate away that shell, and then you have a membrane. But also what it shows is that it's not the shell that's holding that egg in there. It's the membrane. And then when you break the membrane, which you can do, I brought lots of things to clean up after myself. When you break the membrane, then it's really cool to show your kids exactly how thin that membrane is. And then if you really want to take it a step further, God created that shell to protect that bird that's growing in the egg, but then the membrane gives it further protection. And it's so thin and it's so strong, and it does the job that God created it to do. So I have one more science story before I talk about science, and then we do some experiments together. I am, and I've said this before, I am a huge fan of yearly curriculum fairs. I need to see things, I need to go to them, I need to flip through, I need to compare, I need to spend 2 days there. Very rarely am I buying anything the first day. I'm checking everything out. And I'm not the person that's just checking out for the better prices, I'm checking out for the better product. Our third year of homeschooling, I had a second grader. My daughter was in Christian preschool and I have a newborn. At Christmas time of that year, and this isn't a sob story, it's just to sort of set things up. Christmas time that year, my father-in-law had a massive stroke and spent the next 7 months in nursing home care, hospice care, and then he died at home. My husband was traveling all the time, and I'm sort of losing my grip a little bit as a mom with lots of young kids at home, husband that's traveling. When he's not traveling, we were still in the Annapolis area. He's spending his time in Westminster because after walking 3 of our parents out of this world, you have one opportunity to walk somebody into glory. And you want to do it well. You want to do it well, not just for their sake, but you want to do it well so you have that peace in your soul that you did everything you could. So he's traveling back and forth, and sometimes the kids and I would go and sometimes we wouldn't, because it was just really difficult with young kids to make that work. So I didn't get to go to the curriculum fair that year because I don't know, for me, once I had 3 kids and we've got all this family stuff going on with one side of the family, and we've got the other side of the family saying, we're outnumbered, we can't watch your children, there are more of them than us. And I'm thinking, they're not total monsters. I mean, I know they're born into sin and everything that Gary just said, but I'm thinking they're not total monsters. 2 out of the 3 will do what you tell them most of the time. So I had to do all of this shopping through the catalog that year, and there was a program called Good Science. I don't even know if they still make it, but the appeal of Good Science was my daughter would be homeschooling the following year, and according to this text, I could easily adapt it to both of my children. I could easily take the lessons and make 3rd grade activities and 1st grade activities and all of those things, and it would be amazing. So it comes and I look at it and I think, okay, well, I'm not scientific, so it must be me. So every single night, we're starting the next school year, and I'm spending an hour every night just getting ready for science the next day. And my husband looks at me at some point, he said, what are you doing? He goes, because I don't think you realize this, but you're growling. I'm like, I'm not growling. He said, you're growling and you're muttering under your breath. I said, no, I'm not muttering under my breath. I just don't like science. So he picks up the book and he looks at it, and he said, if you're spending an hour every night adapting this easily adaptable science, he said, it's not good science. You need to get rid of it. And I said, I can't do that. I don't have anything else. He said, you're smart. He said, and let's be honest, they're 3rd grade and 1st grade. He said, how much can you ruin science in 1 year? And I thought, I don't know. I think I could ruin it a whole lot in 1 year. So I have nothing to do. He's still traveling. I still have 3 kids. We're in the mix of everything, finishing with his dad and just tying things up, and I thought, okay, I can do this. So I go to the library. I say, I really need some science because I don't have any science. And the library lady suggested the Magic School Bus books. I said, I can't do that for a full year of science. She said, you can, because I know you after, if you remember reading from 2 months ago, we were in the library every week. She said, I think you can. So we did Magic School Bus Science the whole year. We read the books. At the end of every book, there's some type of an extension activity. It's an experiment or a collection or a little research project or something. Because I was reading to them those little bits and pieces that touch on evolution, I can just edit those out in the read aloud portion, and they never know it's there. That, my children told me for years, was their best year of science ever, because Miss Frizzle made it fun, and because we would read the book twice in the week, and we'd do the experiment, and if the experiment was really cool, we'd do it twice, and we'd make collections, and we learned about science in a way that was completely and totally enjoyable. And that was the year that I discovered I really like elementary school science. I really like teaching this. This is really cool. So all my misconceptions about science totally went out the window. And we started teaching it from a hands-on base. And we started teaching it from a Genesis 1 and 2 point of view. And that made all the difference in the world. So a few keys for teaching elementary science. And before I do that, let's talk about the first page of your handout, which is, we're talking today about natural or pure sciences. At least it wasn't the egg, right? And I have to tell Gary, Dad, we broke an egg. It's going to smell bad soon. Science is the perfect opportunity to demonstrate God's creative genius. Contrary to current popular opinion, science often proves the existence of a creator. We know that creator's God, but you can't look at just the natural world around you and really believe that it just happened. You can't. Oak trees make acorns that drop on the ground, and if a squirrel doesn't bury them somewhere else or get them, it grows into an oak tree. Maple trees have spinnerets that if you don't rake them up will grow more maple trees. For years, we had our garden under our mulberry trees, so the mulberries would drop every year. They'd sit there all winter long, and the first thing we'd have to do every spring is pull up seedlings, little mulberries. We have a tree in our front yard that we did not plant, that the tree that was cut down because it was old and it was dead must have dropped something. I'm not sure what kind of tree it is because I'm not a botanist. I love elementary school science, but I'm not very knowledgeable sometimes without a book in front of me. But this tree grew, and we had nothing to do with this tree growing. So you can't look at the natural world around you and say, it just happened. There's no creator. And she's agreeing. Okay, so talking about natural or pure sciences, there are two main branches of natural or pure science. We're not talking physical science or social science or anything like that today. We're just talking natural or pure science. So those two main branches are physical science and life science. Physical science deals with the study of non-living things. That's where we have physics. It's the study of matter, but it's how matter moves. It's how it motions through space and time. It talks about energy and force. How does the universe behave? Physics is that math-based science, but if you understand, then you understand things behave the way they do because God put them in place, but then physics holds them together. You know, in all of these years of having a solar system, there hasn't been a planet that's just spun out of its orbit and gone crashing into another planet. That's physics. That's holding that all in place. Out of all of the planets that there are, and I'm old, so I still count Pluto, even though we don't count Pluto anymore, but we still count Pluto. Out of all of those planets, there is only one planet that can sustain life. That's not an accident. That's a creator. Everything on this planet You good? You want to do science experiments? But everything on this planet is conducive to life. Chemistry is also the study of matter, but we're looking at the changes that matter undergoes. We're looking at composition and behavior and reaction. We're looking at the structure and the properties of matter. So we're looking at it not what it does or why it does what it does, but what is it? What is this stuff made out of? It's atoms and molecules. It's mixtures and chemical reactions. It's all of those things. Earth science, really easy one. That relates to the planet Earth. And then earth science has 4 subtopics. Those would be ecology. We tend to think of ecology and think, oh, this is just about save the planet. It's not. It's the relation of living things with their environment. There is a reason certain trees grow in Florida and they don't grow in Maryland. There is a reason certain animals live in the Arctic Circle and they wouldn't do well in Mexico. There's a reason for all of that. Oceanography. We're talking about currents and waves, and underneath the water itself, plate tectonics and the sea floor, and volcanoes. Geology is the study of the solid earth. It's the rocks that compose the earth. It's how they're formed. It's how they change. And then meteorology is the atmosphere, and it's weather. And it's all of those exciting things you can do. The last physical science topic would be space science. That relates to the study of everything in outer space. So when we think of astronomy, we think of stars and constellations, and they haven't changed. Our relationship to them changes throughout the year because of where the Earth is in its orbit, but they haven't changed. Solar systems. Okay, so we have our solar system, which is our sun, and the 8 planets that orbit around it, and all of the moons and all of the stars. And then we have galaxies in space beyond our solar system. In college, I had a temp job for a year, and when they tested all my skills, I was light secretarial. And I tested very well on answering the phone. So most of my jobs were right along, and I was happy. I was getting paid a bunch of money compared to all my other summer jobs. Well, I landed because somebody else didn't show up, and I lived literally within walking distance. I landed at Space Telescope Science Institute for one summer. Well, they were working on the Hubble that summer. So somehow I went from light secretarial to just answering the phones the first week, and I thought, this is good. Well, the executive director, the man in charge of the whole Hubble project, and this is the summer that it wasn't going well. It wasn't getting off the ground. There were a lot of problems. The mirror for the telescope wasn't right. Everybody was sort of on edge that whole summer. But his administrative assistant had moved to another department. So the temp agency calls and they said, do you want to stay? And I said, I guess so. I can walk. So when I don't have the car, I can just walk here. Sure, how hard can it be? I understood nothing they were talking about the entire summer long, except that we weren't getting the Hubble off the ground, and that most of what I did was hanging up on international phone calls and having no shorthand skills. So anytime he dictated, I'd say, wait, I don't have that. It was interesting. That's my whole story on how I helped get this Hubble into the air. There's really nothing at all. Nothing at all. It was funny. It was one funny story after another every single week. What did I mess up? How did I hinder the Hubble from getting into the ground this week? It wasn't all on me, but I wasn't helping anything. Okay, second branch of science is life science, and that is, just as it says, the study of living systems. So subtopics for life science, which we also call biology, are human biology. That's human anatomy and physiology. It's all of those human systems. What makes people work? What's on our inside? Zoology is the animal kingdom, and we break that down into mammals, reptiles, amphibians, fish, birds, and insects. So you have vertebrates, you have invertebrates. Botany is the study of plant life, and then mycology is the study of fungi, because fungi are alive. They require food, they require oxygen, and they reproduce. And those are the 4 ways to know if something's alive. Does it use oxygen? Can it somehow move? I might be counting wrong. Maybe it's 3 things. I messed up in my math thing last month, and hopefully nobody caught that. And I'm driving home and I'm thinking, I did math wrong. Oh my gosh, I did math wrong just off the cuff. I should never do that off the cuff like that. But anyway, does it require oxygen for life? Does it somehow move? Does it reproduce? And does it need some type of food? If you've got those 4 things covered, it fits into biology. So what are my tips before we do some science? My tips for elementary school science: choose a good curriculum. That's the first tip. I like Answers in Genesis, I like Apologia, I like Sunlight, but there are so many more out there. But what you want to look for, does it have a good mix of text and explaining and things that you can read with activities and experiments? Because the hands-on are what our elementary school students will truly, truly remember. And those are the things that in later years you go back and you pull that back out, especially as you're doing those experiments that are harder, but you did something easier like blowing up your soap in the microwave before. Then you start to talk on a more difficult level. Read books about science and scientists and natures and scientific discoveries, but not textbooks. Fun books. We went through every Magic School Bus book there was. I think there was only one that we skipped because it was heavy evolution and I couldn't somehow weed that out. It would have been editing every other sentence, I think. There's the whole Who Was series that's written on an elementary school level. They have all sorts of famous people, who was Mark Twain, who was Barack Obama, just all sorts of people, but they also have scientists. So obviously you might not want to do Who Was Stephen Hawking or Who Was Charles Darwin unless you have an older student and you're ready to start talking about those things compared to true Bible-based science. But they have Who Was Thomas Edison. I am so thankful for Thomas Edison because I flip on my light and it comes on, and I am very electricity dependent, and I am very grateful for all the work that he did to get what Ben Franklin started to discover inside of my house safely. They have scientists. Read fiction that gives science a starring role. Even if you have to read books out loud to your children, read them out loud. The beginnings of science fiction were Jules Verne and Around the World in 80 Days and Journey to the Center of the Earth, and books that just take all these things about science and make them fun and interesting. Purchase as much as your budget allows, slowly over time, quality science materials and tools. A microscope is the goal at some point in your house, but until then, use a really good quality handheld magnifying glass. When you look at a feather under a magnifying glass or under a microscope and you see how the barbs on that feather, we see so much just with our eye, but then when you put it under and you see that all these barbs hold it together, and you see that the shaft is hollow. So you start to explain to your children, well, birds fly because their bones are structured differently. But then these feathers that they're covered with are hollow as well. And then they have these barbs that hold the surface of the feather together so that they don't flap their wings and the air just rushes through and doesn't hold them up. Try to purchase one of the more expensive items each year. We got a microscope early and we used it all the time in science. And sometimes it was just sliding something under there to take a look at it and see what it looks like magnified. Field trips. There are so many great field trips that you can take that are related to science. We have the Maryland Science Center, which I think still twice a year in the fall and in the spring opens up its door to homeschoolers. Used to be free, might be at a discount place, but upstairs on the 3rd floor there's this entire hands-on science room where kids, just younger kids, just do science and see how things work. You can do nature walks. You can go to a hands-on museum. Lancaster has a really good hands-on children's museum, and they have a science room where you're building pulleys and working with gears and doing all these hands-on things that you might not have room for or the materials for at home. DVDs and YouTube. That's what's so amazing about when you're homeschooling is you can find anything on YouTube. And it's not all bad. There's a lot of really good stuff on YouTube. And as I was researching all of this, there is a site called Hoopla Kids Lab, and they just do these science experiments for you. He shows you how to do it. He tells you how to do it, you do it, and it works just like he said, and he's giving you little bits of science as to why that's happening. Discovery Channel has that How It's Made series, but they also have How It's Made for Kids. So you can watch a 5-minute video on how crayons are made or how hot dogs are made, and I'm never watching that one. But they have all of these things, how it's made, and it's a 5-minute video, and to sit and watch and talk about that's how it's made, that's science also. As you're doing science, work on using, just like with reading and math, we want to use proper terminology all the way through, and we want to check. We want to make sure grammar's in check. We want to make sure we're using the right terms for math. Use the proper science terminology all the way through, even if they don't understand. Okay, instead of saying things just stick together, explain what cohesiveness is. They don't have to understand exactly what cohesiveness is, and we have a really good experiment for that one. But use those terms and then explain those terms. A couple of books that I really like, and sites. There's a site called sciencebuddies.org. This is all in your notes. This is a science website that has a little bit of everything. It's well planned, it's well presented, and it's professional. There are projects, there are labs, there are parent and teacher helps, there are things that your kids can do. We used the TOPS series books a lot. What I like about the TOPS series, and I brought a couple of them, so this one, we're planting corn and beans. And throughout the course of the 20-week or 30-week study, there's an activity that you do each day. There's something that you do, but it was amazing. My children remember what a cotyledon is from this book. It's not from the textbook that we were using at the time. It's because when we were growing the beans, and that's a dicot seed, meaning it has 2 halves, that's where I learned all of this through. Corn is a monocot because it just has one part to that seed. But as we're growing things, at some point you've got your bean plants in your terrarium that you make out of an orange juice box, and you use saran wrap, so it's not expensive and it's all super easy to do. We cut the cotyledons off one of the bean plants, even after photosynthesis was taking place and it had leaves, and that one stopped growing because until the cotyledons fall off by themselves, there's 2 little halves of the seed, they still feed the plant. So my kids are learning terminology just through doing. The more hands-on, the better. And we use TOPS books in conjunction with our science text as well. For kindergarten, we used a book called The Kids' Nature Book. It had 365 indoor-outdoor activities and experiments, and it was perfect for kindergarten science. Easy to do. There are 365 books. Weird and Wonderful Science Experiments, Simple Science Experiments with Everyday Materials. It's literally a science experiment for each day, based on science, simple to understand. What I did find as I was researching for this, there's a book series called the Kitchen Science Lab series, and that's by a woman named Liz Lee. I think it's Heineke. She's a former teacher. She's a stay-at-home mom now. Her bio wasn't real clear if she homeschooled or not, but she has written a series of science books. We're not only doing the experiment, but she's giving you all the science behind it. She's giving you the chemistry behind it and the physics behind it and the biology behind it. So as you're doing these things that you're literally collecting items from around your house or the grocery store or a big box store, she's telling you why all of this works. We used the Usborne books a lot as well because they put things in a smaller bite-sized pieces. My curriculum came with them. We used Sunlight, so it came with a lot of Usborne books. We skipped over the pages and the parts that were heavily evolution, but so much of science experiments, you don't need to really touch on evolution at all. And we really liked the Usborne books for health because it was just a real basic, it was health. We didn't have to be embarrassed until we got older, which was nice. Gave a scientific reason for why you want to wash your hands after you pet the dog and come in and eat your lunch. Just made it far better than mom saying wash your hands. Last thing, science fair experiments, and then we're going to get to some science. So there are 5 basic types of science fair projects. One is experiments. The next one is demonstrations, a research project, a model, or a collection. We only entered science fair projects sporadically, but every year we did a science fair project, and we'd have grandparents come, or we'd have neighbors come, and we'd feed them a snack, and my kids would show off their science fair projects. My youngest, the year that his volcano, we got an old canister from when film used to come in a canister because it was a physical thing instead of a digital thing. So we filled up the canister with the baking soda with the Crayola Model Magic. He made his volcano around it, and then we poured colored vinegar into it, and it, it flows all over the place like lava because it's that scientific, that chemical reaction. So Josh showed it to everybody that walked in the house. We were constantly scooping out the old baking soda, constantly pouring every time somebody came. But the neat thing was, every time somebody came and he demonstrated, he was a little more confident in his presentation. And he could tell you why it was happening. And he could tell you, well, when these two things mix, it makes carbon dioxide. And they'd say, well, what's carbon dioxide? He said, I don't know. It's what these two things make when they mix. But that was the neat thing too, but that by doing the projects, even if we didn't put them in Expo or our local science fair, we did them, and it was cool, and my kids got to present. Online, there is so much science online, and if you find a valid, valuable science website, tap into their ideas. I know this much science, I really do. I just know that we enjoyed it in elementary and we just made it as hands-on as possible. So you've got a little bit of liquid. This will take about a full hour before it finally does it, but at the end all 5 cups will have the same amount of liquid, and these two will have been the colors mixed together. So I'm going to show you one more thing before I give you a choice of some science activities. This is vinegar, okay, and I think we've all seen this one. This is a really easy one to do with kids. It is successful every single time. So you never have to worry about, oh, is this going to work? Is it not going to work? But it's always going to work. And you can, I forgot my funnel, but you can always just make a funnel out of a paper cone. And you're going to dump the baking soda in here quickly. And then right after you do that, you're going to put the balloon on the top.
How much vinegar and how much baking soda?
The more the better. That's my, they don't, you're not going to set your house on fire doing this experiment, which is nice. So some experiments, the bigger the reaction, the more stuff we used, and it was cool. Best science experiment ever is a 2-liter bottle of Diet Coke. I don't know if you've done it.
Mentos.
And Mentos. And I actually don't pour them in from the Mento thing. I actually make a paper sleeve so that I can pull my thumb away and jump back in a hurry. But it only works with Diet Coke. It doesn't work with regular Coke. It's the chemicals in the Diet Coke and the crazy amount of sugar in the Mentos. But it sprays really far. And years that we've had years that we've had the science-based Vacation Bible School, the final night is always Mentos and Diet Coke. And the last group is lucky because they usually get like a mini Mentos Diet Coke show, because I'll usually have about 3 Diet Coke bottles left. So we just go down the line really, really fast. Oh, this overflowed. Okay, so maybe a little bit less. Okay, so what those two things are making together is carbon dioxide, and then carbon dioxide is the gas then that fills up the balloon, and it will fill it to a certain period of time. So again, you're just explaining to your kids that 2 things mixed together can create a gas that can then expand something else. So I have a few experiments to try, and I've totally messed up my table at this point. So if you want to grab a lab partner, you can grab a lab partner. I have created 2, I keep walking away from the mic. This one's not going to look as polished. Sorry. I have 2 scientific method sheets. Scientific method says the first thing I do in an experiment is I make an observation or I have a question. So one of the experiments that I have today involves pennies and water, and it's a cohesion experiment. So the first thing is, what do we want to explore? So with this penny experiment, we're actually going to drop 1 drop at a time water on a penny to see how many drops of water the penny will hold. That would be my question. Hypothesis, what's my prediction or my best guess? How many drops of water do I think that penny's going to really hold without spilling off? So I'm going to make my hypothesis. I think that the penny will hold 6 drops of water, and the 7th drop will push it over the edge. Then my procedure. So I actually have lab cards for this one. What am I going to do? First, I have a materials list. Okay, my material list is a penny, a bottle with a dropper top full of water, and then for the very last step, a bottle of soapy water. And I'm going to write the steps down in my procedure part. And then I'm going to follow all the directions. You're going to follow all the directions, and you're going to write your results. What actually happened? And why did it happen? Why do you think you got as many drops of water on the penny that you did? and then at the very end, when the one dropper full of soapy water, what happened and why? So there's basically a cartoon one that you would want to use with, like a comic strip setup, that you'd want to use with younger children. When we were doing this in the beginning grades, K through 3, we drew a lot of pictures. We didn't do a lot of writing. We drew a lot of pictures. As they got older, we started using a scientific method worksheet where they didn't. So, one experiment I have involves the water and the pennies, and another one involves a soda can and a balloon. So, if you want to choose partners and figure out which one to do, I'm going to give you your 2 lab sheets, your scientific method sheets, and then you actually have a lab sheet. Okay. But everybody will get the lab sheets at the end. Okay, so you get a penny, you get these 2. And you are doing the experiment at the bottom called heat of water. So you just want to be, now you are getting, I'll give you 2 balloons and 2, and we don't drink Mountain Dew, just so you know. I needed empty cans. I think you can do this on a cubed. So what you want to do first is you're going to blow up your balloons. I don't have a lab sheet for you. You're going to blow up your balloons. You're going to rub it on your heads to get that static electricity going, which static electricity, of course, happens because you've got negatively charged electrons interacting with positively charged protons, and they are creating static electricity. Then what you can do is you can put the Mountain Dew can on its side on a pew. You want a flat surface. And with the side that you've rubbed against your head, see how it reacts and what you can get it to do. Okay?
You said we do or don't write this down?
No, you can write it down. That way you get used to the scientific method.
That's 3. I really want to go the rest of the day with my hair standing.
Here, I can rub it on my head.
He has a test, so he would love it. He would love to go the rest of the day with his hair on. You're going to be the guinea pig, right?
Oh, wait a minute. Something's not right then.
Yeah, by the 3rd one, it was gone.
Yeah, I think the table's going downhill, that's one thing.
Oh.
And then this kind of forward,
Oh, okay.
It's not dropping.
Is it not dropping?
one.
Yeah, that's not. No, see, it's already come off. That's why it's not.
When you get your hair all set.
I wonder if it would work better on the floor because the floor might be more flat. And then try to drop it as slowly as you can.
We're supposed to meet our hypothesis before we can
There's 3, that's 3.
We should make observation first, right? Yes. And then we have.
Nope,
and then
yeah.
pressure-based observation, and then conduct experiments.
I'm sorry, that one, I don't know why that one's not working.
What? Okay, David, soda can on the side.
I also have no life.
I think this is coming up.
I think, yeah.
Is it?
You're getting it's hard to
Did you just see that? It was attracted. Mine was attracted. Is yours coming towards yours or going away? I think it was attracted. Yeah, did you see this?
14, yeah.
Okay, so now what you want to do is you want to do it again and pile it up again, so that it's still cohesive. And then the last part is you drop the soapy water on it.
Okay, so just go to,
Yeah.
take it over.
Yep. And it's okay if you want to do like one less, so make sure that you still have that.
Attraction to the static.
Yeah.
That's what you're doing now, so it's gonna be that. And, okay, so. Question based on this observation. Yeah.
I think I spilled it. Just put a drop of soap?
Just one, yeah, should be on your lab card.
Yes, one more.
Please suggest this one. Please suggest this one. Okay, that's fine.
Right. So what happens is the agents in the soap break water's cohesiveness because you've introduced, like water's cohesive because all of the molecules, it's all like molecules. So they all like. So they all pull together and hold together because of that cohesive property. Yep. Which I've totally learned from this book. I haven't learned it anywhere else. So it all holds together, and you can heap a lot of water on that penny, far more than you think you can, right? Because water will hold itself together. But that little bit of detergent in there just disperses all of it because you've broken the cohesiveness. You've introduced another element that then messes up the polarity of water and all of that. So
Wait, what is this? What book are these from? Are they
these are the Tops books.
Okay, yeah, I'd like to see what's like.
Oh, go right ahead.
Are they still available?
They are still available. You can buy them online. They have them all the way through high school as well. So if you get a high school curriculum that you don't like the science as much, we have these four, but then we also had electricity and magnetism. And electricity was cool because with just aluminum foil and batteries, we're creating circuits and lighting light bulbs and blowing up balloons and setting things on fire. And all of those.
I wouldn't even say you have to come back at least 8 times 10 times.
And you can adapt it. Like not all of that book is appropriate for elementary school, but certain projects are, especially if they're parent led.
I'm definitely going to get you.
So did you just sort of work through it and then picked another topic?
That's what we did, yeah. That a lot of years was my curriculum. Oh, I didn't do the right thing here. We had some basic text with Sunlight, but then Sunlight was actually the one that got me introduced to the Top system. And then a lot of times the particular book we were using I didn't like so much, so we'd get the Tops.
Yeah, I'm using Rebecca, and it's theoretically, but I find it's giving you more like, okay, here's like appropriate to the fourth grade, and then we just take, okay, this is the topic we're gonna do. We jump all over the place. I let them pick for themselves what they want to do, but we go way off.
Yeah.
So we kind of use the text, but then we don't, but then we write a lot of that, which is humidity killer.
And that's where all of these things that I mentioned, that's where they really come into play.
But I have hypothesis stuff, so the higher the question.
But the one set of resources Kitchen Science Lab books by Leslie Heineke. You couldn't use them as your full curriculum, but definitely to supplement them with the science experiments, because she doesn't just give you this really cool experiment, but she's telling you this is why it's working. This is what branch of science it falls into. This is the chemistry or the physics or the whatever behind it.
So I use something like that, do not recall them. Maybe
No?
maybe I didn't use it too much for the elementary, but the higher something like that, do not recall.
Okay, it might not be, Sunlight usually switches to Apologia by high school, and I love Apologia. I like certain curriculum more at the high school level than the elementary school level. So what I very purposely did, I love Wordly Wise, and I think Wordly Wise is great SAT prep, but I didn't use Wordly Wise at all in elementary school and middle school because it's the same format all the way through, and I didn't want my kids to burn out on Wordly Wise and then in 9th grade say, oh, more Wordly Wise, hooray. So we used something else, and then they only had 4 years of Wordly Wise, and all 4 of my kids said this really prepared us for the SATs. I love Apologia Science, and I love the younger Apologia Science, but we didn't use Apologia Science until 8th grade for the same reason. I didn't want them to look at it and say, we've done this, we know this, we really, until 8th grade, we really pick and choose a lot for science.
And that's what I'm thinking. I have a 4th grader and a 1st grader. And the 4th grader, I mean, science is her thing. And the 1st grader, she likes it, but she's very mature.
Okay.
So I try to do a lot of stuff together. Well, that's a ton, and then I've got 2 little ones.
Yeah.
So that's always a struggle of how do I fit everything in and make it work. And science, I feel like it's one of the subjects.
Absolutely. We did science together until my kids started hitting 8th grade. And the thing about science, like math and reading, you lay that foundation and you keep building and building and building. And if you didn't lay the foundation down here, when you get here, you've got huge gaps. But science and social studies are cyclical, meaning what we do in elementary school, we do it again in middle school, more in depth, a little more complicated, more knowledge, more terminology. And then we do it again in high school because the branches of science and the smaller branches that are branching off, they haven't changed. We haven't made a whole lot of striking brand new scientific discoveries that they're constantly changing textbooks. But, so what they do here, and you make it hands-on, they get to middle school, you go a little further in depth. You do hands-on that's a little more complicated. They get to high school. So my approach with science and social studies was, what we do here, if they get it, it's great. And if they don't remember it, it's okay because they're going to get it again, and they're going to get it again. And they're probably going to get it again at some point. And each time they get it, that it's repeated, like, oh, I got it. I remember that. Okay, I have a couple experiments that I want to show you up here before we stop.
What age do you introduce the pH scale to kids usually? Is it a little older?
You can do it whenever, really. It's not going to make a whole lot of sense when they're too young, but if you just start talking about it, and they can start to understand that some things are chemicals and some things are bases and some things are more acidic, and a lot of what you can do with that too at a young age is they can, if it's not a harmful substance, they can taste it. My kids who wouldn't eat, half of what was on their plate sometimes, if you say it's in the name of science, they'll dip their finger in vinegar and say, oh, this is really awesome. Okay. science worked with that brief period of time when we were canning things and saying, oh, look, this is like the Mrs. Frizzle book when they get in a pickle, and here we're making pickles, and isn't this fun? Come help me can pickles. And they're like, yeah, you're not Mrs. Frizzle, Mom. I'm like, darn. Okay, so there's one. This has to do with surface tension. So you want to blow up a balloon as much as you can until you pass out on the floor, so that you have a really tight surface tension. And then you're going to take a piece of tape and you're going to put it on one side of your balloon. And then you're going to turn around and you're going to put another piece of tape on the exact opposite. And if it works correctly, I didn't get it to work entirely correctly last night, but we'll try it again. So, say a prayer that this time it works. You can take a skewer. Just make sure your skewer is sharp. Now, if it doesn't work, it's going to be big. Oh, you have no confidence in me. Yeah, I don't know. It didn't work. That was awesome, wasn't it? Science gone wrong. Oh, I'm so sorry.
She'll be fine.
Everything blows up properly, and I think I used the wrong kind of tape, but that was really a lot of fun, wasn't it?
And masking tape?
Masking tape might work better, or the flat, not the shiny stuff. You should be able to put the skewer in and put it out through the other side, and it's surface tension that's doing that. Okay, I'm going to do an experiment that involves fire, so you want to come up for that one. This is sort of like a party trick experiment. It's chemistry, but it's also how can you do this? Okay, so I've got a little hole in this box of matches. And just to be on the safe side, a little tiny hole that I made with the skewer. And just to be on the safe side, look, I'm pouring water so I can dump everything right into a cup of water if it doesn't turn out the way it's supposed to. You want to empty your box of matches. That's a safety precaution. Okay, so you put one match here. You might want to stand up to watch this. And then you put a coin here. Just all over this. Now the trick is to say to your friends, this is like a cool thing, can I remove this coin without making this match fall? Too many matches in my hand. It's really important that you remove the match. It's really important that I try to do it this way. Okay, this one you obviously do with your child. You don't let them do that on their own. Okay, so can I remove that coin without making that match fall? So this one doesn't take long to work, so you do want to watch it carefully. Okay, I'm going to light the match right. Nope. We went through a lot of matches last night. My husband finally just got me a glass of water and said, here, just dump them in here. Good idea. Like, he has no faith in me. Because he knew me when I hated science, when I constantly said, oh, I hate science. Okay, so you're going to light the match below what catches on fire. Now, it should work. Oh, it didn't work. This one takes a while. There is nothing wrong if a scientific experiment doesn't work, because what that gives you, it gives you the opportunity to do it again. And it also tells your child, or demonstrates to your child, I guess, The fact that by the time something is scientific law, we have done experiment after experiment after experiment and gotten the same results over and over. And a lot of times experiments don't work, not because they don't work, it's because it's operator error. Okay, so you're lighting this match right here. Now watch, and it didn't do it again. I'm having a really hard time with this one. But now I'm just determined that it's going to work.
I'm really curious what it's supposed to do now.
I know. See, I'm building anticipation. Once we got a science experiment that truly, truly worked, a lot of times we tweak something, we change something from time to time so that my kids could see, oh, look, this works, but it didn't work this way. Why? What was different? And of course, we went all over the place last night looking for matches. And I can tell you all the places that no longer sell matches.
Are you serious?
That you would think,
Really? I would think that's like a standard.
no. I finally sent my son out to get them on his way home from school. I said, I gotta go home. I can't look for matches anymore. And he goes, oh, they sell them at the dollar store. So I tried Michael's. And even though they sell candles, they don't sell matches. I tried CVS. Because it's all in the same shopping center. They don't sell matches anymore. I tried the gas station thinking, well, that's where you buy cigarettes, so they should have matches. They only have the lighters and the match books. And I tried one or two other places, and finally Josh said, yeah, I know where to get them, I'll get them for you. I said, I'll even take it back. Oh, is it going to do it this time? It should do it. It's not doing it. When it works, what happens is this match will actually come up. They'll fuse together, and it's a chemical reaction. So they fuse together. Here, we'll try one more time. Hopefully this time it'll work. And then if not,
So like the match heads fused
the match
together.
heads fuse together.
Wow.
But you have to start the flame on, and I found this one online. You have to start the flame on the match, not on the match heads. Okay. We're gonna pray this one works. Because Gary's gonna watch this and he's gonna say, you're spilling everything. Nope. And you're trying to set my church on fire. Okay, well this one was on one of the websites that I saw. It might have been on one of the Hoopla Kids videos, but it does. It's so cool because what'll happen when it works is it just comes up and it kind of hovers there for a minute, and you can just sort of flick the quarter out.
So the question is, can I remove the quarter without that match falling?
Right. And obviously you don't put your finger under there while the matches are burning. That, you know, my boys loved anything they could light on fire, or when we do the Tops electricity one, you do steel wool shavings and you set them on fire. So of course we did that one several times. You pop a balloon with electricity. You know, and what I like about the Tops is it's all things we could buy at the grocery store, we could buy at Walmart. We didn't have to order anything. They have quite a few books. I know they have at least 25 books. And the thing is, they are by grade level, but you can do them with any grade level. So here,
Where they sell them? Like, are they on?
online. There, right now, and here everybody can take one of these. The heap of water one is the really cool one to do at home. So I think that's it. Are there questions other than why my experiment didn't work? But see,
Other experiment worked, Susie, so.
yeah, but that one was so cool. And then here you can see we've got green going on here, we've got purple going on here, and just, you know, the paper towel just pulls it, and if you let it sit long enough, by the end, they all have the same amount of water, because water's going to go to a common level.
So, obviously in high school, you're usually zeroing in and spending a year on each different type of science. But for elementary school and even middle school, did you still do that with your kids, where you would spend a year on life science and so on and so forth, or were you more like all over the place? A week, a month, a semester?
Part of the reason we use Sunlight is because it wasn't a set text until 8th grade for science and social studies. It was a combination of things. It was pulling from here and there. It was a combination of lab books and text-type books. And we really sort of did a little bit of everything throughout the course of the year. When we got to 8th grade, we did, I think that's when we started Apologia. So we did the Apologia general science in 8th grade, then we went through physical science, biology, chemistry. Usually by 12th grade they were either done or they were doing something at the community college. By high school science, they're doing that at co-op or with a tutor, because I
What do
can't
you
do
like
it.
particularly about Apologia? Like, what is better about it in your opinion?
In my opinion, it is so biblically based. And even the high school, I have read out loud all of the Apologia high school books to my kids, so we have that side-by-side learning element. I don't understand anything in the chemistry book. It's just words going through. But it's so biblically based. And he writes from a point, we still have all the J. Weil books. So he writes from the point of being this absolute science genius. But he's talking to you like you don't know anything. But it's not from a stupid point of view. It's just, you don't know this, but I get it, and I love it, and I'm going to show it to you, and I'm going to teach it to you. He writes from this point of view of, this is exciting, this is my thing, and I want to, when you get excited about something, you're sharing it with somebody. It's all that energy, it's that excitement. So that's how he writes. And even though I didn't understand that chemistry book, I did enjoy reading it because of the way he wrote it. I'm looking at my kid the whole time, whichever kid, do you get this? Oh yeah, I get it. Okay. I don't get it. That's all that matters. And they'd go off and do the on your owns and everything else and do the experiments in their co-op or their tutoring class. But it's not as dry, I think. Yet at the same time, it's definitely in-depth. I tell my families, if you do 100% of that Apologia, the experiments, all of the tests, that's an honors level high school credit. Now you have to do 100% of it.
You mean the 4 grades through high school?
Right, the high school. Because it really truly is. And there are other texts that are...
Do they have more than 4 though? Like, they have a bunch of different
They
options
do.
that you can choose.
They do. They have physical science biology, then they have advanced biology. I think they have marine biology or zoology. They have
And they have more
chemistry,
than, like, 4
advanced
years worth, so you
chemistry.
just, like,
Oh
had to
yeah. Physics, advanced physics. Am I missing any?
So is it...
Ruth is saying, that sounds
Should you
okay.
just tailor that for a child, like what that child's interests are? Like, say you have a kid who is interested in marine biology, you might do that instead of zoology or whatever the other options
It's
are.
also your goal. And I work with my parents really early in high school as well. Is your goal college for your child? Then you're going to need physical science, biology, and chemistry to get that transcript college ready. Plus, it also gives them the edge. My daughter went to a Christian college, so all of her sciences were from a Christian perspective, and that was good. My oldest went to a state school, and it was so good to have that really firm biblical foundation that when he's hearing one thing, he's also my black and white one. He's just sorting it out in his brain saying, yeah, it's so not true, but I'm going to do what you want me to do anyway. Or I'm going to, and he was my one bold enough to say, this is the answer you want, but I don't agree with this answer, but I know it's the answer that's going to give me the good grade on the test. And I was
Isn't
like,
that terrible that we have?
but
We should at
I
least
also...
pose it as theory.
Right. But I also worked early with my kids, not too early, but once they started to differentiate, we did talk about evolution at the end of elementary school because I wanted them to be knowledgeable and not just say, well, that's wrong because the Bible says it's wrong. They need more than that.
Yeah.
They need to understand it is theory and it hasn't been proven. But at the same time, evolution with a little e isn't really evolution, it's just adaptation. There is a difference, and adaptation is happening. And that's why you had all those finches with those different beaks. It wasn't evolution, it was they adapted to where they were living. And the other cool thing is if you take that back to the flood, here's the really cool thing. Our neighbor was in the Air Force, and he was stationed all over the place. And he had fossils that he had collected throughout his years of being stationed everywhere. And when he was in Saudi Arabia and all of these desert places, all of the fossils that he collected were marine fossils. They were clamshells, they were marine life, they were fully fossilized. Well, that just gives proof to the flood. So if and my kids have a couple of these fossils.
And they find the seashells up on mountains, the seashell fossils up on mountains.
Right. So you find these things, and they all give proof to the Bible account of everything. And then if you go from there and say, okay, well, what happened after the flood? We had to disperse. And that's why you see adaptation. But we talked about evolution early because I wanted my kids to have a strong argument against. I didn't want them to get out there somewhere and say, oh, I don't know what to do with this. We never talked about this at home. But not too early either.
So for you with your kids, up until 8th grade, you were just kind of dabbling in everything throughout the year to give them a taste and an enjoyment.
Right. But then also what Sunlight did is it gave me, because we use Sunlight, it gave me that stack of books instead of just the single textbook. Mm-hmm. But it's all easily adaptable. I mean, if you're using a Becca or Bob Jones or something that's more of a standard text that doesn't have a lot of the activities or the experiments per se, then you find other things. You find kitchen experiments to do. You find experiments. We always had food coloring in the house, and somebody was always doing something with food coloring. Always. And, I know. And I thought, well, look. And, we weren't free and easy with it. We did have goals, but we did make sure that we were hitting all the areas and branches of science each
for you,
year.
Make sure you're comprehensive and it gives you a structure. You know
Right.
where you're going next.
Mm-hmm. And then you just pull to make it more exciting. I had a mom in the Westminster program when I took over the Westminster program. Before it was the Westminster program, we were just part of a different private Christian school. And I basically got a pat on the back and said, good luck with this family. And they'd come to their reviews and they wouldn't have the right amount of work done ever. And I'm thinking, oh my gosh, what is going on here? Well, they came to their year-end review, and her boys she only had boys, had all of these great things that they had built and science projects that they had done. And I'm looking at the curriculum, I said, okay, it's not you, it's not your boys, it's your overall curriculum. There's no hands-on. So we changed the curriculum. And the next year was like night and day. Her boys liked school, but it was a matter of we just we had to change some things. I've got a mom in the Westminster program. She is amazing. Her boys did the small volcanoes, and they loved it. She's got all boys. They hunt, they do taxidermy, they work on that with Dad. But that's science, because they're like, I said, Danielle, please tell me. She goes, I have one girl room in my house, and they're not allowed in that room, and I decorate it the way I want, and it doesn't have any animal heads hanging on. But she's such a great mom, a boy mom. She's such a great boy mom, because she took that volcano thing, and they wanted to start using all different materials instead of just the baking soda. And so they built in a kiddie pool in the yard a volcano structure. And then they just started seeing what they could dump into that thing that would, and it was great. And they spent weeks on it, but it was a building project and it was a science project. And because she's so in tune with her, and I just thought, I envy you. I envy you, because I didn't pick up on some things with my kids like I should have. And I tell her, I use this story all the time, because you picked up that they wanted to expand it and do more, and they were keeping all their scientific method notes and all of that, and writing stuff up and telling me about it at reviews. And then when something didn't work, they'd say, this didn't work, and here's why it didn't work. We went online and we researched it. But then it was just so cool. She's got this picture in this kiddie pool and this volcano that they built over chicken wire with Dad, and everything they dumped into it and everything that worked. They did the Diet Coke and Mentos and just had that. So, yeah, find a curriculum for your base, but then if it's not giving you everything, there's just so much. There's so much to do for science.